Audio Jungle. Audio Jungle.
Welcome everyone to my YouTube channel. Today I want us to look at moles, the mole concept in chemistry. And just on the screen there's question number 2, which says period 3 contains the elements sodium to argon. This question asks about the chemistry of each of the period 3 elements or their compounds. Let me just show you what they mean by period 3 having sodium all the way to carbon. So that's my periodic table right there. If you check well on the third row, that's our period 3 right there. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So that's our period 3. Basically, that's what the question is trying to say. Now, I won't do the whole question, but I'll only focus on the moles part because this video is about moles. So part A says sodium nitrate is a white crystalline solid. When heated, it melts and this reaction occurs. The sodium nitrate liquid being heated to give us sodium nitrite plus oxygen. Now that's a simple equation. A word equation would look this way. A word equation would be sodium nitrate nitrate giving us sodium nitrite nitrite plus oxygen plus oxygen gas. All right, now 3.40 grams sample of sodium nitrate is heated, and the first point there asks for the number of moles of sodium nitrate used. It's important for you to know that sodium nitrate is the first chemical in that equation, the NO3. NO2 is sodium nitrite. Now, we have two basic formulas for working out moles. The first one, which almost everyone knows, is that mole is given by mass divided by the RFM. Okay. The second formula is mole is given by CV. Yeah? CV, or we can say C times V, where C means concentration, sorry. Is the concentration, what we can call molarity. That's our concentration. And then V is the volume. So up to this point, by reading that question, we have realized that the second formula, this one right here, will not be of help to us in this particular question because we don't have the molarity, we don't have the volumes given. So we'll use the first formula. Moles for sodium nitrate, we'll use the first formula, mass divided by the RFM. RFM stands for relative formula mass. So I'll just come here and drop down my formula and say mole is given by mass over RAM. I mean RFM, RAM is for a single atom. And the mass is given there. So mass is 3.40 grams or 3.4 grams. So I'll have here 3.4. Okay, 3.40. Now the RFM of sodium nitrate, we'll have to add the relative atomic masses of the individual atoms, the sodium, the nitrogen, and the 3 oxygen atoms. Now, from the periodic table, we can locate sodium. Sodium is number 11 right there. Let me just use a different color of pen for us to see it easily. green can work. So sodium is number 11, and then nitrogen is number 7, and then oxygen is number 8. So the numbers below these elements are the relative atomic masses. Let's start with the sodium. Sodium is 22.990, as you can see in the table. We round that to the whole number, which is 23. Nitrogen is 14.007. As a whole number, it will be 14. And oxygen is 15.999. As a whole number, that's going to be 16. So I just come back to my question and continue solving. This compound, sodium nitrate, has one sodium, that is a single 23. We add one nitrogen, 14, and then we add 3 oxygen. That's going to be 3 times 16, because oxygen's atomic number was 16. Atomic number is also called mass number. So if you do this accurately, let me just plug this in my calculator. You end up with 3.4 divide 85. Okay. And if you further divide that, you get your number of moles of sodium nitrate used to be 0.04. Okay, that's our answer for that part of the question. Going forward, they want the number of moles of oxygen formed. Now, as stated earlier, we can easily just say that mole is given by mass over m. Mass over, in this case, we call it relative molecular mass, because oxygen gas is a molecule, O2. But you realize that there's no mass of oxygen given, and we don't have the moles, because the moles is what we want. So there's no way this formula can help us. In such a case, you use the previous number of moles that you found, the 0.04 for sodium nitrate, and apply the mole, the ratio concept. So you'll have to check in that equation up there, the ratio of sodium nitrate, because the sodium nitrate is what we have solved already in the first part, the ratio of sodium nitrate to oxygen. So during balancing of that equation, sodium nitrate was multiplied by 2. So that is our proportion for sodium nitrate. Oxygen is, there's a 1 multiplied by oxygen there. You can't see it, but a single O simply means there's a 1 up there. Okay. Now, the ratio of sodium nitrate to oxygen is 2 to 1. That means 2 equals to the number of moles of sodium nitrate. Okay. And then we want to find what 1 would give us in terms of moles, because 1 is the number for oxygen. So we do cross multiplication. This is just normal maths now. It means 1 multiplies 0.04, and then 2 is divided down there. If you do this well, you end up with 0.02 moles. That's the moles of oxygen. Okay. Now, the third section of this question is about molar gas volumes. Okay. Molar gas volumes. And it says volume of oxygen formed in cubic decimeters. Now, let me just make this clear. A decimeter cube, or 1 cubic decimeter, is the same as 1 liter. Okay. And that's also the same as 1,000 cubic centimeters. Now, when we are dealing with units in the laboratory, especially the school laboratory, okay. So 1 cubic decimeter equals to 1 liter, which equals to 1,000 cubic centimeters. This will be helpful in conversion, but in this question, we are very lucky because the answer is given in terms of dm to the power 3. So we don't need to convert anything in this case. Now, in brackets, there is the statement measured at RTP. This is the most important part in this section, because at RTP, This we can apply in any other question which looks the same way. At RTP stands for room temperature and pressure. So at room temperature and pressure, this is what happens. 1 mole of a gas, 1 mole of gas gives us 24 dm cubed volume. Okay, so we have the moles of oxygen in the second part of the question, which is 0.02. So we want to check how much volume will 0.02 mole of oxygen give us. Okay, then just like normal maths, we have to do cross multiplication. Okay, so we do that cross multiplication, you end up with 0.02 multiplying 24, and then you're dividing by 1. Okay, so if you multiply 0.02 by 24, let me just do it in my calculator, you end up with 0.48. So 0.48 liters is our volume of oxygen. Okay, so in the next video, I'm going to go a bit deeper in terms of molar gas volumes.